Friends of the brain, get ready for a new dose of wonder. Today, we are going to uncover one of the most fascinating secrets of our thinking machine. We are going to explore the world of savants. Have you heard of them? These are people with extraordinary, almost supernatural mental abilities which contrast with significant limitations in other areas. Imagine for a moment someone who can draw an entire city from memory with photographic detail after seeing it just once. Think about a musician who, without ever having taken a single lesson, can play any piece they hear or even compose complex symphonies. There are those who can perform complex mathematical calculations in seconds, as if they had a built-in quantum calculator, or memorize entire books after a single reading. They are like superheroes of the mind, but their superpowers often arise from a mysterious combination of neurological differences. And here is the really mind-blowing part that we are going to dive into today. What if I told you that science can sometimes predict the existence of these astonishing talents even before we see them manifest in a person? How is it even possible to know that a type of savant is missing from the map, as if it were a puzzle piece that hasn't been found yet? Think of it like a brain detective. But we are not talking about a detective looking for clues to a crime. Instead, this is a detective looking for patterns in the way our brain is built. It is as if we have a big brain instruction manual, and by studying it thoroughly, we can start to see gaps or possibilities that tell us certain types of extreme abilities could exist, even if we haven't yet met someone who possesses them. The history of science is full of examples where, solely with logic and pattern observation, the existence of things we hadn't yet seen has been predicted. The most famous example is the periodic table of elements. Dmitry Mendeleev, that Russian genius, not only organized the known chemical elements, but by seeing the gaps in his table, he predicted the existence of unknown elements. He even predicted their exact properties long before they were discovered. And guess what? He was right. Elements like gallium or germanium were found years later with the exact characteristics he had foretold. Is it possible that our brain, that complex marvel, has its own periodic table of abilities and dysfunctions? Could neuroscience be in a similar position to Mendeleev, predicting the existence of savants with abilities we haven't yet documented? The answer is a resounding yes. And what allows us to do it is far more fascinating than you imagine. Exactly how do we apply this incredibly powerful logic to the gray matter between our ears to unravel the secrets of the invisible and predict talents that seem straight out of science fiction? The key lies in how our brain works. Imagine your brain as a gigantic metropolis. It is a place with millions of streets, buildings, and districts, each with a specific function. There are districts for language, for memory, for vision, and for emotions. Everything in this city is interconnected by an amazing electrical network of neurons. Neuroscientists, armed with increasingly sophisticated tools like MRI scans and EEGs, are mapping this cerebral city with unprecedented precision. It is as if we have a very detailed map of the city where we can see every street, every intersection, and how the traffic of information flows through it. When we study people with savant syndrome, what we often find is that their brains are not normal in the statistical sense. They often have some kind of damage, dysfunction, or difference in certain areas. And this is where the analogy of the Russian scientist becomes crucial. Just as Mendeleev noticed that existing elements grouped into patterns and that there were gaps suggesting the existence of other elements, neuroscientists notice patterns in the brain. We know that certain brain areas are more or less active in different tasks. For example, the left temporal lobe is usually heavily involved in language. If that area is damaged, a person may have difficulty speaking or understanding. But what if that damage, in some way, awakens a hidden talent elsewhere? This brings us to one of the most powerful theories to explain savant abilities. It is called disinhibition or the release of functions. Think of your brain as a giant orchestra. Normally, there is a conductor, which is the frontal lobe. This conductor controls planning, logic, and judgment to ensure all instruments play in harmony. But there are also musicians who suppress or moderate others. Imagine that certain neural circuits, say those responsible for trivial fact memory or the ability to process details, are constantly braked by other circuits that handle the big picture or abstraction. If the orchestra conductor or the neural brakes are damaged or function differently, what happens? Some instruments, which were previously muted or playing very softly, can suddenly start playing at full volume. It is as if a barrier were lifted. A person's savant brain might, in some cases, have a dysfunction in the areas that normally inhibit or filter information. This would allow them to access a level of detail, a type of processing, or a memory that remains inaccessible to the rest of us. This happens because that information is normally being filtered or suppressed for the sake of overall efficiency or the big picture. For example, in some cases of acquired savantism, where abilities emerge after a brain injury, it has been observed that the damage occurs in brain areas normally responsible for executive functions like planning and rational decision-making or social interaction. When these areas lower their guard, other areas, perhaps related to associative memory, pattern recognition, or visual and spatial processing, can take over and manifest with surprising intensity. Another key piece of the puzzle is brain plasticity. Our brain is not a fixed structure. It is incredibly adaptable. If a part of the brain city suffers damage, the traffic of information can be rerouted through new paths, or existing paths can become more efficient. It is as if a main road were cut off and traffic engineers found an alternative route or even built a new highway so that the flow of vehicles wouldn't stop. In the case of savants, this extreme plasticity could allow certain brain areas to compensate for the deficits of others, developing astonishing abilities in the process. Sometimes, this is not so much compensation as a recalibration of resources. If the brain isn't expending energy on complex social skills or long-term planning, those resources can be reallocated and used to process numbers, memorize data, or perceive patterns in a way that would seem impossible to us. So, how do we actually test these predictions? The analogy of the elements helps us understand how we can predict types of savants. If we observe that damage to region A sometimes results in ability X, and damage to region B in ability Y, we can start to draw a map of how different brain configurations might lead to different superpowers. If we see a gap in that map, or a particular combination of brain characteristics, perhaps an inactivity in the prefrontal cortex and an hyperactivity in the right temporal lobe, should produce an ability we haven't yet seen, then we can postulate the existence of that type of savant. But we do not just stick to theory. Today's science allows us to go a step further and test these hypotheses. One of the most amazing tools at our disposal is transcranial magnetic stimulation, also known as TMS. Imagine a device that can send magnetic pulses to specific areas of your brain and temporarily turn them on or off, just like a light switch. Scientists have used TMS to temporarily silence certain parts of the brain, especially those in the left anterior temporal lobe, which is believed to be involved in functions like language and high-level cognition. And guess what happened? When they turn off that part of the brain in non-savants, some subjects show a temporary increase in savant-like abilities. For example, they can become incredibly fast at proofreading, able to spot errors that previously went unnoticed, or they may improve their artistic skills. It is as if by silencing that part of the brain that normally filters or categorizes information in a certain way, other parts are liberated and can process raw details with astonishing intensity. This is not only a fascinating proof of the disinhibition theory, but it is also like a preview of what we might expect to find in the savant catalog. If we can temporarily induce these abilities, it gives us valuable clues about what natural brain configurations might be producing them permanently. When neuroscientists talk about predicting savants we have never seen, they are not doing random futurology. They are applying logic similar to the logic of the periodic table. They are looking for patterns in brain dysfunction and compensation, and in doing so, they identify gaps in our current knowledge. These gaps represent possible combinations of abilities and deficiencies that, based on what we know about how the brain is organized, should exist. This leads us to think beyond already known cases and to actively search for people with these predicted brain configurations. It is an exciting frontier of neuroscience that not only helps us understand savants but also our own normal brains. Because if some extraordinary abilities are latent within us, just waiting for the brakes to be lifted, what does that mean for the unlimited potential of the human mind? We are looking at a future where we might understand these hidden codes more clearly. Savants are an extraordinary mirror that shows us the incredible potential of our brain, which is often hidden behind everyday functions. They remind us that there are hidden codes, neural shortcuts, and latent talents that we are only just beginning to decipher. Every time we find a new way to understand how the brain adapts or how it releases its inhibitions, we move closer to filling in those missing pieces of the puzzle. The brain is not just a collection of parts working together, it is a dynamic, shifting landscape that can reinvent itself in the face of challenges. The next time you see an incomplete puzzle, think about the possibility that its gaps are telling you about pieces yet to be discovered, and about talents yet to be born. Our journey into the science of the invisible shows us that just because we haven't seen something yet doesn't mean it isn't there. The patterns of the brain are waiting to be read, and the superpowers of tomorrow might already be written in the neurological gaps of today. We are constantly learning that the human mind is far more expansive than we once thought. By studying those who think differently, we gain a deeper appreciation for the variety and depth of human experience. The brain city is vast, and there are still many districts left to explore. If you found this exploration of the mind's hidden potential as fascinating as we did, make sure to give this video a like. There is so much more to discover about the mysteries of the human brain, and we are just getting started. To stay updated on all our future deep dives into the science of wonder, don't forget to subscribe to the channel. Thank you for watching. For more information, visit minrora.com.